All right, so you know how much we love like digging into the inner workings of how things work, those hidden systems that make the world tick.
Hmm.
Well, today, buckle up because we're going deep on a concept that might just completely revolutionize how you view like the entire universe.
Whoa.
We're talking about inequality choreographies.
Yeah, it's not like discovering a new particle or force or anything like that. It's really about taking a totally different perspective or framework on looking at reality itself.
Exactly. Our source material is an excerpt from an academic paper
Okay.
with a pretty sci-fi title, Inequality Choreographies, a new lens on a physical reality.
Catchy.
Yeah. But don't worry, we'll break it down so it doesn't feel like we're lost in space, right?
Right.
What's the mission for this deep dive?
Well,
To understand how this idea of inequalities being like the driving force behind everything can actually like help us make sense of the universe.
yeah, the paper argues that these inequalities or differences in things like energy, pressure, temperature, they're what create a sort of natural choreography, driving the universe's evolution.
So it's like the universe is constantly striving for balance, but never quite getting there.
Yeah,
And in that struggle, all these incredible patterns and structures emerge.
that's a great way to put it. The paper really stresses that these inequalities, these gradients, are like the engine of change in the
Oh,
universe.
okay. I'm intrigued, but can we get a concrete example?
Sure.
How does this like inequality choreography actually play out in a way that we can all like wrap our heads around?
Think of a hot cup of coffee.
Okay.
When you leave it on your desk, the heat from the coffee naturally flows out into the cooler air,
Right.
trying to even out that temperature difference, that flow of energy,
Yeah.
that movement is a simple example of an inequality choreography in action.
So the universe is kind of like a giant coffee cup, always trying to reach like a uniform temperature,
Yeah.
but creating all these fascinating swirls and currents in the process.
Precisely. And the fascinating part is that the paper suggests that this happens spontaneously without any need for like a grand plan or a cosmic conductor.
Yeah.
The universe, it seems, is a self-organizing system driven by these inherent inequalities.
It's funny. I was reading about how organizations solve problems,
Uh-huh.
and it struck me that they often cycle through like old solutions, almost like trying them on for size before settling on like a new approach.
Yeah.
Is that another example of this inequality choreography at work?
You're picking up on some key themes here.
Okay.
The paper refers to this as the principle of itinerant attractors.
Okay.
It means a system doesn't necessarily settle on a single stable state, but jumps between different attractive states driven by those underlying inequalities.
Got it.
It's a bit like your brain trying to recognize a new smell.
Okay.
It doesn't just match it to one static pattern, but jumps around exploring different scent memories until it finds a match.
Wait, so my brain is doing a cosmic dance every time I smell something new.
Kind of, yeah.
That's wild. So you're saying this same principle applies to the way that like organizations grapple with a new challenge.
Mhm.
They're essentially sniffing out solutions.
It's a fascinating parallel, and it highlights how this concept might apply to more than just physics.
Right.
It could be a powerful way to understand systems of all kinds, from brains to businesses to entire galaxies.
This is where things start to get really mind-bending because if we follow this line of thinking, it leads us to question some pretty fundamental assumptions about reality.
Yeah.
In fact, the paper even suggests that space-time itself might not be as fundamental as we think.
Yes, the paper proposes that space-time might actually be a consequence of these deeper processes, these inequality choreographies, playing out at a level that precedes what we perceive as space and time.
Okay, hold on, space-time, the very fabric of reality as a consequence of something else.
It's a big idea.
I need a minute to process that one. You're telling me that the stage emerges from the dance itself.
Think of it this way. The dancers are those fundamental inequalities, constantly trying to resolve themselves according to a principle called the principle of least action, which basically means the universe is always seeking the most efficient path. And as these dancers move and interact, they create the very stage upon which they perform space-time as we know it.
Okay, I'm starting to get like a glimmer of this,
Yep.
but I definitely need some more concrete examples to really like wrap my head around it. The the paper does mention some pretty fascinating applications of this framework, especially when it comes to explaining some of the biggest mysteries in the cosmos, like black holes.
Absolutely. Black holes are these incredibly dense objects with such strong gravitational pull
Yeah,
that nothing, not even light, can escape them.
right.
They're a bit like the ultimate cosmic vacuum cleaners.
Right. So how does this idea of inequality choreography help us understand those cosmic enigmas?
Well, the paper suggests that black holes can be seen as ultimate gradient sinks.
Oh, okay.
Remember those inequalities we were talking about?
Yeah.
Imagine gravity creating such an extreme difference in density that everything gets pulled towards it, creating a point, infinite density.
So it's like all these inequalities are trying to resolve themselves, but just keep getting sucked into the black hole forever, caught in this cosmic whirlpool.
That's a great way to visualize it. And this new perspective might help us understand things about black holes that we couldn't before, like how they influence the evolution of galaxies and even the distribution of dark matter. We'll delve deeper into the mysteries of black holes and dark matter in the next part of our deep dive. But first, let's take a moment to recap what we've uncovered so far about this fascinating concept of inequality choreographies.
All right, so we've established that inequality choreographies could be this hidden engine driving the universe. Last we left off, we were about to plunge headfirst into one of the biggest mysteries in astrophysics.
Black holes.
Black holes, those cosmic enigmas that gobble up anything that gets too close.
Yeah.
Exactly. I'm still trying to wrap my head around the idea that they're like giant cosmic vacuum cleaners sucking up everything, even light itself.
And what's even more mind-boggling is how this idea of inequality choreography helps us see them in a whole new light.
Okay.
The paper suggests that black holes act as gradient sinks.
Okay, remind me again what's a gradient?
Remember how we talked about inequalities?
Yeah.
Gradients are essentially differences in things like density or pressure. Imagine these differences becoming so extreme near a black hole that everything gets pulled inwards, creating this point of infinite density.
So it's like all these inequalities are desperately trying to resolve themselves, but just keep getting dragged into the black hole like moths to a cosmic flame.
That's a great analogy. And what's fascinating is that this perspective might allow us to understand things about black holes that we couldn't before.
Like what?
Well, for example, how black holes influence the evolution of galaxies. Those swirling masses of stars and gas spread across the universe.
Yeah, like our own Milky Way.
Exactly. Black holes with their intense gravity are thought to play a key role in how galaxies form and change over time.
Right.
And this framework of inequality choreographies could provide new tools for understanding these complex processes.
It's amazing to think that something as seemingly destructive as a black hole could actually be playing a crucial role in the grand cosmic ballet.
Absolutely. And speaking of mysteries, this framework also has some pretty thought-provoking things to say about another cosmic enigma, dark matter.
Ah, yes, dark matter, that invisible stuff that makes up a huge chunk of the universe, but doesn't interact with light. What's the inequality choreography take on that?
Well, here's where things get really speculative,
Okay.
but also incredibly exciting. The paper proposes that dark matter might be a symptom of inequalities operating at a level that precedes space-time as we know it.
Wait, are you saying before the Big Bang, like before time and space even existed?
Not necessarily before the Big Bang, but perhaps in those very first moments when the universe was still incredibly hot and dense and space-time was just beginning to emerge from this chaotic soup of fundamental forces.
So the idea is that dark matter is like an echo of these primordial inequalities, somehow influencing the structure and expansion of the universe even today.
That's the gist of it. It's a pretty wild concept. But it fits within this larger framework of inequality choreographies, being the fundamental driver of reality. It suggests that these inequalities might be imprinted on the very fabric of the universe, shaping its evolution in ways we're only just beginning to understand.
It's mind-blowing to consider that something we can't even see or directly detect could be playing such a significant role in shaping the cosmos. It's like trying to understand the choreography of a dance by only seeing the shadows it casts on the wall.
That's a brilliant analogy, and it raises an important question. If these inequalities are operating at such a fundamental level, before space-time as we know it, how can we even study them? How do we know they exist?
That's a great question. It's like trying to study the blueprint of a building that hasn't even been built yet. Where do we even begin?
This is where machine learning comes.
Yeah.
And the paper describes machine learning as an ontic bridge between data and reality.
Okay.
Might sound a bit technical, but essentially means machine learning can help us uncover hidden patterns and complex data that we humans might miss.
So it's like having a superpowered detective that can sift through mountains of data and find clues that point to these underlying inequalities.
Exactly. Machine learning algorithms can analyze vast amounts of data from astrophysics, cosmology, and other fields, potentially revealing subtle signatures of these pre-space-time inequalities, even if we can't directly observe them.
Okay, so machine learning could be the key to cracking the code of these hidden cosmic choreographies. That's pretty amazing.
It's a powerful tool that's already revolutionizing many fields of science, and its application to cosmology is incredibly exciting. Who knows what hidden patterns and connections we might uncover with its help?
So we've gone from black holes to dark matter, exploring how this idea of inequality choreographies might help us understand some of the biggest mysteries in the universe. But I'm curious, does this concept have any relevance to us here on Earth? Does it apply to our everyday lives?
That's a fantastic question, and it leads us to the most exciting part of this deep dive, exploring the potential applications of inequality choreographies to understanding not just the cosmos, but ourselves and the world around us.
All right, we're back for the final part of our deep dive into inequality choreographies.
Okay.
We've journeyed from the heart of black holes to the invisible realm of dark matter, and now it's time to bring it all home.
Yes.
How can we actually apply this mind-bending framework to our own lives and the world around us?
Well, this concept invites us to see the world not as a static picture,
Right.
but as a dynamic dance of inequalities constantly being resolved.
Okay.
And that dance, that choreography is happening everywhere, from the smallest cells to the largest societies.
Okay, I'm seeing the big picture, but how do we actually use this idea?
Right.
It still feels a bit abstract to me. Like, should I be looking for temperature gradients in my morning coffee?
Well, maybe not literally, but the key is to become more aware of these choreographies playing out around us, to notice the imbalances, the tensions that drive change in our own lives and in the world.
So it's about paying attention,
Yes,
noticing the patterns, and maybe even anticipating where those inequalities might lead. Like, if I can understand the steps, maybe I can learn to lead the dance.
exactly. By understanding these dynamics, we might be able to make more informed decisions, navigate challenges more effectively, and even contribute to shaping those choreographies in a positive way.
You know, it's funny. I was reading about how cities grow and evolve, and it struck me that they're constantly responding to these kinds of inequalities, differences in population density, access to resources, economic opportunities.
Yeah.
It's like the city itself is doing a kind of dance trying to resolve these imbalances and find a more harmonious state.
That's a great observation, and it highlights how this concept applies not just to physical systems, but to social systems as well.
Yeah.
Think about the inequalities that exist in society. Inequalities in wealth opportunity, access to education. These imbalances create tensions that can drive social change, leading to movements for equality and justice.
So just like that cup of coffee trying to reach a uniform temperature, societies are constantly trying to resolve these social and economic gradients, creating these complex patterns of change in the process.
That's the idea. And while it's a simplification, it helps us see that change isn't something to be feared, but rather the natural outcome of these inherent inequalities. It's the driving force of evolution, innovation, and progress.
It's starting to click for me now. Instead of resisting change, we should embrace it, understand the forces that drive it, and learn to move with the flow.
Precisely. And this framework can be a powerful tool for understanding not just how things change, but how we can influence that change for the better.
So it's not just about understanding the dance,
Hmm.
but about learning to dance ourselves, maybe even choreographing a better future.
Beautifully put. This concept challenges us to see ourselves not as passive observers, but as active participants in this grand cosmic ballet.
This has been an incredible deep dive.
Yeah,
We've explored the universe, delved into the human brain, and even touched on the dynamics of social change, all through this lens of inequality choreographies.
absolutely.
I feel like I've gained a whole new perspective on how the world works.
It's been a fascinating journey, and I hope our listeners inspired to continue exploring these ideas and to see the world with new eyes.
Before we wrap up, is there anything else you'd like to leave our listener with, something to ponder as they go out into the world and start seeing these inequality choreographies everywhere?
Hmm. I'd simply encourage our listener to look for those inequalities, those gradients in their own lives.
Right.
Where do they see these choreographies playing out in their work, their relationships, their communities, and how might they use this understanding to navigate those challenges to create positive change, to dance their own unique dance in this ever-evolving symphony of the universe?
That's a beautiful thought. Thanks for joining us on this incredible journey.
My pleasure.
We'll catch you next time on The Deep Dive, where we'll continue to explore the hidden patterns and unexpected connections that shape our world. Until then, keep those minds open, those questions flowing, and keep on dancing.